Amis, do you see it?
Yes, we can see it. Thanks.
Yeah, perfect. Yes, as I said, I will present some work that we have done on tackling data quality when using low-cost sensors in citizen science projects. And also, as David said, I'm a researcher at the IVL, Swedish Environmental Research Institute, and I have worked with air quality measurements for many years. I started working with standardized air quality measurements at the NILU, the Norwegian Institute for Air Research, and then I have, before my PhD, and then I have now continued working with air quality measurements. I've done a lot of measurements in the atmosphere. Yes. As said, I work at the IVL, the Swedish Environmental Research Institute. For those of you who don't know this, it's the Swedish leading organization for applied environmental and sustainability research. We are an independent research institute in the fields of environment and sustainability. And we are, of course, we have offices in Sweden, but I also would like to mention that we are also represented in China and also in India. So it's not only Sweden. And it's not only air quality, but today I will focus on air quality and air quality measurements. So the outline for my talk will be a bit about standardized air quality measurements, even if I know that even if I know that this should be about low-cost sensors, I can't talk about low-cost sensors without putting it in the context of standardized air quality measurements. And then I will talk, or kind of follow that up with making a suggestion for a data quality strategy for citizen science projects. And for those of you who know me, I also need to say a few words about possibilities with passive samplers. Even if it cannot maybe not be defined as a low-cost sensor, it's the low-cost air quality something you can do measurements with. And then I will show some examples from ongoing projects and some take-home messages. That's my plan. And it would be a bit of my my journey working with low-cost sensors from working in the public sector in the municipality with control of air quality standards, and then to where I am today. So let's go. Yes, this is how I visualize how you could use different kind of instrumentation and data quality or ways to work with different data quality for different applications when you do air quality measurements. This is how I visualize it, and this is how I like to think about it. So it might not be correct. It's not the correct version maybe, but this is how I think it's useful to think about it. And this figure will come back several times in this presentation. This is how I will build my argument. And then to explain this, let's see. Do you see the pointer? No? Yeah. Okay. It's a very strange. Now I have it like I want. Sorry. I think we have, as you know, we could have approved air quality instruments, and then you can have sensors. So you have different range of instrumentation for measuring air quality. And then depending on which application you have or what the aim with the measurement is, you could choose either sensors or these approved air quality standard instruments. So, and And even if you choose like a good instrument and expensive instruments, you still need to do the work with the data quality to be sure that what you're saying or thinking that you're measuring is what you're measuring. So that is, yeah, it depends. It doesn't really depend on if you choose low-cost sensor or not. And this is also, yeah. So then you can see that you can go this there with required data quality here, and then the different depth is how we have thought about it of the different applications for the data, air quality data. And when you get higher up on this stairs, you will also require increased knowledge and labor and resources for your measurements or for the use. And on the top here, here we have the standardized air quality measurements. And for doing these, you need to have used the standard instruments. And these standardized air quality measurements are used to control air quality standards. It's in Europe, it's in the European Directive for Air Quality. It's under revision, so here is the limits values that are in the new suggested in the new directive. And these limit values are legally binding for the member states. So the member states need to fulfill that their levels of air pollutants are lower than these levels. And in this directive, it also describes like selection of sampling sites, methods to use, quality control of the data, maintenance, calibration, blah, blah, blah. It's very, it's very detailed, and it's very, not very flexible. And then I know that you can have opinion that, oh, but it's only a few sampling points. There should be more measurement sampling points, or the limit values are too high. It should be lower, and so on. And I totally agree that it would be better if you have more measurements and if you have stricter standard air quality standards. But there is something very, very nice, very good in having these directive and getting measurements that are comparable and follow these standards, even if it's expensive, it requires a lot of work and so on. You will get measurements of concentrations that you compare and that you could then study. You can see here is from Gothenburg. An example for Gothenburg is nitrogen dioxide from 1976. So you can see that the concentration has decreased over the years. And since we are doing these standardized measurements, we can compare the numbers from years to years, and you can see that it is decreasing. And we can also say the same when you compare numbers in Europe, if you do follow the same standard. And this is extremely, in my opinion, this is extremely powerful and good. And then you need to follow these requirements. Here is an example of an instrument that you need to use. They're big, they're expensive, and you need to have a place to put them. This is also from Gothenburg, one of the measurement stations in Gothenburg. Yes. Yeah, and for standard measurements, and if you want to control that you fulfill these air quality standards, then you require a high data quality. But the sensors, the low-cost sensors, they are open for other applications, and maybe we should try not to mimic these the standardized air quality measurements, but try to look at other ways of using air quality measurements. For example, in this citizen science project, having a citizen science approach. Let's see. So I get back to my stairs, or to how I think about air quality measurements. Up here, you need to have the standardized measurements, but there are a lot of useful applications further down that don't require the standardized air quality measurements and don't require the same data quality. So now I will try to suggest or describe a way that you could do to create useful data for citizen science projects. Okay, this is the air quality data, or at least it's the air quality measurements. You see it's PM 2.5, you have the dates. You can think that we are measuring with like more instruments here. Maybe there are two different instruments since they're different colors. But in principle, this could be like air quality measurements. But without a context, this kind of measurements are it's useless. They can't be used to anything. So you need to have information about the metadata. Yeah. So in order to put these measurements into a context, you need or make them more useful. Of course, it could just be numbers, right? If you don't have information, for example, about the instrumentation of the siting, where it is measured, measurement height, for example, influence of local sources. Is it outdoor measurements or indoor measurements? We don't really know just from the data series. What is the calibration procedures? We don't know. And the maintenance. So in order to produce useful data, you need to have, or the metadata is the key. I will show you one example from the Love IoT project that we worked with. And this is Johanna's master thesis. So here you have, we wanted to find out if we could use these low-cost sensors and use low-cost sensor to measure, to see the effect of a construction site in the middle of Gothenburg city. So the yellow here, inside here, there is a large construction site. And then at the green and red points, we placed sensors. And then the yellow point up here is the reference station where they have standardized air quality measurements. Okay, so we have these sensors around these construction sites, and we know, since we put them out, or Johanna put them out, so we know where they are. We know where the height, that they are placed in a good position, and so on. Okay, so here you have the data from November to December, the 26th of November to 2nd of December. And then the different colors are the different sensors. Doesn't really matter for you which sensor is which, unless the green one here. The green sensor is the sensor that is placed here at 3, so it's close to Hagakyrkan. So here is how it's placed. You can see it's placed here, so it's over the door or entrance to this church. And my point is here, and then you see that they are following each other pretty well for the start of the period, and then suddenly happens here at some point during this period, the green sensor, or this sensor measures much higher levels than the other. And then when we look in, and that could be okay. And I guess, and that is like in data science, we could kind of just figure a way how to handle this. But what my point is here, that we found out that this particular evening, there was an event in this church. So there, and during these hours where we saw elevated levels, they had put a candle or something outside the door, the entrance. There was this Christmas concert, and that's why we measured so high concentration during this period. And as I said, this is something that, of course, you can handle in data. Yeah, you can handle it. But if you don't know if the sensors are close to a source that will influence them, then it's hard. If you, for example, have a sensor that is placed close to a chimney or something else that will influence all the time, you don't really know. So you need to know where it is to use to be able to produce useful data. And another example also from the Love IoT project, you probably know the data community that has PM 2.5 sensors in, when I checked, it was 71 countries, and it was a lot of data. They're collecting a lot of data. And we tried to find out if we could use this data for validating Stockholm's dispersal modeling, because it would be useful to have more measuring points to compare the modeling with. So what we did is that we took the sensor that is within a 20-kilometer radius from the Stockholm Central Station. And when we did this, we had 49 sensors. And then we did some criteria for which sensor to include. And one of the criteria was that, okay, we tried to mimic the directive. So we had to have 90% data coverage for 1 year in order to make a yearly average. And then we excluded 39 sensors. We have only 10 sensors left. Okay, that is fine. But then when we tried to look at it, we didn't find any metadata for the sensor. So we don't really know anything about the sampling sites, if they're indoor, outdoor, and anything like this. And when we try to compare it, you can see here, it's not really clear, but the red is the yearly average of the sensor, and then the gray is the lowest modeled value for yearly value, and then the black is the highest. And then when we analyzed this, we didn't really see a trend. And since we didn't know anything about the metadata, we couldn't use this as we hoped. So I hope I made my point clear that you need metadata is the key to create useful data. Okay. So how to create this metadata and how to do this to create good data and useful data for citizen science projects. And yeah, I will get back to that. If you should start how to use these low-cost sensors, I think the first thing you do, if you have a sensor like this, I have the background, but we have the sensor, then you need to find out what is the detection limit, the uncertainty in the measurements, the working condition with temperature, with relative humidity, and so on. And I know for many this is so basic, but I really think this is something that you often forget to do this first. Because with this sensor, it's a PM 2.5 sensor, we try to use this for applications where you don't really measure a difference in PM 2.5. The levels are so low, so we are not really expecting anything can't see anything here in Gothenburg with this. Okay, but if you have found out that you can use your sensor and know the limitations of it, then do the intercomparison of the sensors for a longer time. We also have seen, I have several of these sensors in my office, but if you compare these two, we know it's important to compare sensors of the same type. To do an intercomparison for a longer time. And then you can see when we have done this with these sensors, we see that they are measuring the same thing most often. Here we did, this is from the Nordic Path project, we did an intercomparison at the church roof. But that is not where we wanted to do the real measurements. We wanted to do the real measurements in traffic. So then we also had to put all these sensors on a bike and compare it in a representative in a representative environment. And then if you have all these, you can also see how you can use the sensor much more. And the second step here, or not the second step, but what you also could do to make your data even better is to compare it with standardized measurements. But this require that you have access to one of these stations, or at least you can measure close to it. So here you have, again, these two sensors at the top of one of the stations in Gothenburg. And you see it's the lower panel here. We compare it with the reference data, and they are not really working as good as we hope. So, but if you have this information and know how to handle it, then you can create useful applications, I think. So, just to sum up what I just said, check the working conditions of your sensors, the limit, detection limits, and temperature, and so on, relative humidity. Do an intercomparison for a longer time. Longer time depends, but at least a couple of days a week, maybe longer if it's possible. And then do intercomparison in a representative environment. These two could be done at the same time. And then, if possible, you could do the co-location with standardized air quality measurements. But as you're going through here, doing this citizen science, using the local sensors in citizen science is not, it will require some expertise and access to some infrastructure. So maybe what I have thought quite a lot about recently is that if you could do, you could do things with the data and with the low-cost sensors without doing, you need to check the working conditions, but maybe not, you don't really know, not always need the co-location with the standardized air quality measurements if you know how the sensor work and designing your measurement strategy. So you don't require it. Okay, and then I would also like to say that if you don't have the expertise and technique or technical expertise or infrastructure to do all these kind of comparison, but still want to use measurements for citizen science, passive samplers can be a possibility, and you have seen that in the literature that they are used for citizen science project. And then it's just a small little disk up here. You don't need to have any technical expertise. Bad thing, low time resolution and no real-time data, so it's not so sexy as these sensors, but it's very useful. So here you can see we have three of these at 3 sites close to our road to see the air pollution levels at a preschool in Gothenburg. So some examples from the Nordic Path project. For one nice thing with using local sensors and using it in citizen science project is that you could increase the spatial resolution of your measurements. So we have 4 cities in the Nordic Path project. And this here is, we have these sensors that we put on bicycles. And then you can see it's possible to get quite high spatial resolution with measurements. This is just a measurement. We are not analyzing the data. And then if you have static sensors, you could also have more sensors placed around in the city compared to the reference stations. And in Kristiansand, they have some issues with wood burning. And here it's model data from Kristiansand from 2 years, so November in 2020 to February 2021, and November 2021 to February 2022. And what we see, if you compare this panel with this, is that this modeling are not capturing the local variations where there is problem with wood burning in Kristiansand. So these, if we could use these sensors for citizen science projects, we could increase the knowledge about wood burning or emissions from wood burning in, for example, in Kristiansand, where the models do not capture that pretty well yet. Okay, so finally, my take-home messages. is that in order to tackle air quality or data quality in citizen science project using low-cost sensors, I think it's crucial to define the purpose of the data collection first. We have seen, and I also have done so many projects and tried to work with sensors and not have defined this purpose first, and then it's so hard to use the data. And then, as I said in the beginning, maybe we do not always need to mimic the standardized air quality measurements, but try to use the sensors for other applications that don't require the same data quality. And then when you have defined the purpose of your data collection, then you can define a suitable quality assessment, quality control approach to ensure that you get the data quality that you need. And then based on that, then you have to assess if that is possible to establish this quality assurance, quality control in your project. If you have the expertise that is needed to meet this, and I think you need to use this sensor. I think you will need both, and try to get high up on here. You need to have both people that knows air quality and air quality measurements, but also data scientists. And that makes it much more fun to work with this when you have both. And also for citizen science projects, I think it's important to communicate both the possibilities but also the limitations in the data, so they have realistic expectation for what we can use the data that is collected. If we do this, then we could use these sensors for very they could be very useful in this citizen science project, and I think it could be really powerful tool for citizens to work with air quality for different applications. I think that was it. Thank you. Any questions?